Lesson 6.1.2 Adding and Subtracting Polynomials. Question 6. In this problem, we are asked to simplify the given expression. Notice that each trinomial we are adding consists of three different terms. In each of these trinomials, we have a k-squared term, also called the quadratic term, and the variable for this term has been raised to the second power. It has an exponent of 2. The tile that represents this term is a large square that measures a length of k along each of the sides. Both trinomials also contain a k term called the linear term. The variable for this term has been raised to the first power. It has an invisible exponent of 1. The tile representing this term is a rectangle with the dimensions of 1 unit by k units, so that the area of this rectangular tile represents 1k. Finally, the trinomials possess a constant term. This term does have a variable, and it looks like it is just a number. The tile representing a constant term is a small square unit tile that measures 1 unit by 1 unit. The differences between these terms is very important, because we can only combine terms that are similar. To represent our first trinomial visually, we gather 5 k-squared tiles to model the 5k-squared term. Next, we use 7 linear rectangles to represent the 7k term. And finally, the negative 2 units can be represented by the 2 negated unit squares. The coefficients of each term tell us how many algebra tiles will be needed for each type of tile. Do you think you can represent the next trinomial? What do you think it might look like? If you want to pause this video and try on your own, do so at this time. The representation of the second trinomial contains 7 quadratic squares, 9 linear rectangles, and 4 negative unit squares. And now let's look to see what the full polynomial with both trinomials looks like. Remember, the problem is asking us to simplify the expression. To do that, we combine like terms. If terms are like terms, they have the same variable with the same exponent. Algebraically commute the like terms so they are next to each other. Using our algebra tiles, we do the same thing. We rearrange the tiles into their 3 groups. Now, when we add the terms, ask yourself how many quadratic or k-squared terms are there in total? How many linear terms? How many constant terms? To do this algebraically, factor the variables from each set of like terms and add the coefficients. To find the answer using the algebra tiles, just count the visual representations for each like term. Notice, the result of adding these 2 trinomials yields a polynomial that is also a trinomial of degree 2. It is a simplified version of the original problem.